Look up at the stars tonight, and what do you see? Pinpricks of light scattered across an endless dark canvas. But thousands of years ago, our ancestors saw so much more. They saw gods riding fiery chariots, cosmic serpents swallowing the sun, and great battles waged in the heavens. These weren't just stories, they were humanity's first attempts to explain the mysteries of the universe. And what's truly astonishing, many of these ancient myths hold uncanny parallels to the science we're uncovering today. The Greeks imagined Atlas holding the sky aloft. Now we know about the invisible forces shaping the cosmos. The Norse spoke of a world tree connecting realms. Modern physics reveals a universe woven together by quantum threads. It's as if the ancients glimpsed fragments of truths they couldn't fully understand, encoding them in legends that would echo across millennia. This isn't just coincidence. From the Babylonians charting planets to the Maya calculating celestial cycles with jaw-dropping precision, early civilizations observed the heavens with a rigor that rivals modern telescopes. They tracked comets, predicted eclipses, and built monuments aligned with the stars, all without the tools we take for granted. But here's the twist: their science was wrapped in myth. A supernova wasn't just an exploding star, it was a deity's fiery birth. The Milky Way wasn't a galaxy, it was the spilled path of a goddess's milk. These stories weren't mere fantasy, they were frameworks for understanding a universe far more vast and strange than they could fathom. And somehow, against all odds, they got startlingly close to realities we've only just begun to prove. So what if these myths weren't just poetic guesses? What if they were humanity's first scientific hypotheses, dressed in the language of their time? That's the journey we're embarking on today, a voyage across centuries and cultures, where dragon-swallowed moons become lunar eclipses and creation stories hint at the Big Bang. We'll unravel how the same cosmic truths emerge, whether carved on clay tablets or glowing in supercomputer simulations. By the end, you'll never look at the night sky or the stories we've told about it the same way again. The universe has always been speaking to us. The question is, were our ancestors listening closer than we realized? Take the ancient Babylonians, who gazed at the night sky not just with wonder, but with the precision of mathematicians. Their myth of the Enuma Elish begins with a swirling, formless void, a cosmic ocean of chaos called Tiamat. Sound familiar? It's strikingly close to what scientists now describe as the primordial soup of energy before the Big Bang. But here's what's even more remarkable. The Babylonians didn't stop at poetic descriptions. They meticulously tracked the movements of planets, recording their positions on clay tablets with such accuracy that their data still holds up today. They could predict lunar eclipses centuries in advance, all while believing those celestial events were signs from the gods. Then there's the Egyptians, who aligned their pyramids with uncanny precision to the stars of Orion's belt. To them, these constellations weren't just patterns, they were the gateway for pharaohs to join the gods in the afterlife. Their myth of the sky goddess Nut, arched over the earth, swallowing the sun each evening and giving birth to it each morning, mirrors our modern understanding of Earth's rotation. Even their calendar, tied to the flooding of the Nile, was regulated by the star Sirius, proof that their myths and their science were inseparable. And let's not forget the Antikythera mechanism, that baffling bronze device recovered from a shipwreck. This 2,000-year-old Greek computer could calculate planetary positions and eclipse dates with gears and dials, a masterpiece of engineering that blurred the line between astronomy and mythology. To its creators, the planets were still the wandering gods Hermes and Aphrodite, yet their mechanical model of the cosmos was shockingly advanced. What all these cultures shared was a dual vision, the heavens as both a spiritual realm and a mathematical puzzle. Their myths weren't just fanciful tales, they were frameworks, attempts to make sense of patterns they observed but couldn't yet explain. When the ancients described dragons devouring the sun during an eclipse, they were grappling with the same cosmic truths we study today, just through a different lens. Their stories were the original theories of everything, written not in equations but in epic poetry and star maps. And in many ways, that makes their achievements even more extraordinary, because they reached for the stars with nothing but their eyes, their intellect, and their boundless imagination. The Greeks didn't just see gods in the stars, they saw entire dramas unfolding, stories that somehow captured truth about our solar system long before telescopes or space probes. Take Mars, fiery and red in the night sky, named after Ares, the god of war. It's almost as if they sensed its violent past the ancient floods, the colossal volcanoes, the rusted iron dust that gives the planet its blood-like hue. And then there's Venus, shimmering and beautiful, named for Aphrodite, the goddess of love. Beneath that radiant glow, we now know, lies a hellscape of crushing pressure and acid clouds. A stark reminder that beauty can be deceptive, something the Greeks understood all too well. But their myths went even deeper. Hephaestus, the limping god of fire and metalworking, wasn't just a blacksmith, he was the force behind volcanic eruptions, forging weapons in the heart of the earth. Today, we've found his workshop on other worlds. Mars's Olympus Mons, the tallest volcano in the solar system, would have been right at home in his mythology. And Jupiter's moon Io, with its hundreds of active volcanoes spewing lava into space, is like something straight out of an ancient Greek epic. It's as if they glimpsed the fiery nature of these distant worlds, even if they couldn't see them clearly. Then there's the story of Icarus, the boy who flew too close to the sun. For centuries, it was just a cautionary tale about hubris until NAS, a Parker solar probe, did the unthinkable. Flying through the sun's corona, enduring temperatures hotter than molten steel, the probe echoed Icarus's doomed flight, but with a twist. This time, science triumphed where wax and feathers failed. The Greeks imagined the sun as Helios driving a chariot across the sky. Today, we know it's a nuclear furnace, yet the essence remains, a cosmic force both life-giving and dangerous. What's fascinating is how these myths weren't just random stories. They were frameworks, ways of making sense of a universe they could observe but not yet measure. When they told of Athena springing fully formed from Zeus's head, could they have been hinting at the sudden, explosive birth of ideas, or even the way new celestial bodies emerge from cosmic chaos? Their tales of titans trapped beneath the earth mirror our discoveries of tectonic plates shifting, of mountains rising and falling over eons. The Greeks didn't have the tools we do, but they had something just as powerful: curiosity and imagination. They looked at the heavens and saw not just points of light, but a grand narrative, one that we're still unraveling today. Maybe that's the real lesson here: science and myth aren't opposites. They're two languages telling the same story, just separated by time. And when we listen closely, we realize the ancients weren't just storytellers, they were the first scientists, reading the cosmos in the only way they knew how. Now picture Yggdrasil, the gargantuan ash tree of Norse myth, its roots drilling into unseen worlds and branches cradling the cosmos. This wasn't just a poetic image, it was a startlingly accurate metaphor for realities modern physics is only now uncovering. The Norse envisioned 9 realms dangling from Yggdrasil's branches, each with its own laws and beings, from the icy wastes of Niflheim to the fiery forge of Muspelheim. Fast forward to today, and string theory proposes a multiverse where countless universes float like soap bubbles in higher dimensions, each with its own unique physics. The resemblance is uncanny, ancient storytellers describing a fractured cosmos long before scientists coined terms like brain or quantum foam. Even more chilling is Ragnarok, the cataclysmic battle where gods, giants, and monsters perish in flames, only for the world to regenerate anew. At first glance, it's just an epic doomsday tale until you recognize the eerie parallels to thermodynamics. The heat death of the universe, where entropy consumes all energy, leaving a cold, lifeless void, mirrors the Norse vision of a cosmos cycling through destruction and rebirth. Modern cosmology suggests our universe might not end with a whimper but a crunch, collapsing inward before exploding outward again in a new Big Bang. The Vikings, huddled around fires in frozen longships, somehow captured this grand cosmic rhythm in their sagas. What's truly mind-bending is how these myths encoded abstract physics without the tools to quantify them. The serpent Jörmungandr, encircling Midgard with its tail in its mouth, isn't just a monster, it's a perfect symbol of the cyclical nature of time, a concept Einstein's relativity would later formalize. The Rainbow Bridge Bifrost, linking Asgard to Earth, evokes wormholes or space-time warps long before general relativity. Even Odin's self-sacrifice hanging from Yggdrasil for 9 nights to gain wisdom feels like an allegory for scientific inquiry, suffering uncertainty to glimpse deeper truths. This wasn't primitive superstition. It was proto-science using narrative to grapple with questions we're still answering. The Norse didn't have telescopes, but they had something equally powerful: observation and imagination. They noticed patterns, seasons dying and reborn, stars wheeling in predictable arcs, and wove them into a cosmology that, stripped of its gods and giants, aligns with our expanding understanding of reality. Maybe that's the real magic here. Humanity's relentless drive to decode the universe, whether through runes or equations, always leads us back to the same astonishing truths. Deep within the sacred verses of the Rig Veda, written over 3,000 years ago, lies a description of creation so precise it sends chills down the spine of modern physicists. The Nasadiya Sukta doesn't just tell of God shaping the world, it describes a moment before time, when there was neither existence nor non-existence, only a shimmering potential. That's not mysticism, it's quantum physics in poetic form. The ancient Hindus envisioned the universe bursting forth from Hiranyagarbha, a golden cosmic egg floating in primordial waters. Strip away the metaphor and you're left with an eerie precursor to the Big Bang singularity, a single point of infinite density birthing everything we know. But the parallels don't stop there. The same text describes cycles of creation and destruction spanning billions of years, with universes breathing in and out like a sleeping giant. Today, cosmologists debate oscillating universe models where big bangs lead to big crunches in an endless loop, a theory that would have felt right at home in a Vedic sage teachings. Even wilder, ancient Indian astronomers calculated the speed of light with jaw-dropping accuracy. In the Surya Siddhanta, a text dating back at least 1,500 years, they described sunlight traveling 2,102 yojanas in half a nimsha. Convert those ancient units, and you get roughly 186,000 miles per second within 1% of the modern value. How did they possibly know? The answer lies in their unique worldview, where science and spirituality weren't at odds but intertwined. Take their concept of Akasha, the invisible fabric of space that carries sound and light. It's strikingly similar to our idea of the quantum vacuum, a seething ocean of virtual particles popping in and out of existence. When the Vedas speak of Maya, the illusion masking reality's true nature, it mirrors quantum mechanics' observer effect, where particles behave differently when measured. These weren't just philosophical musings, they were frameworks for understanding a universe far stranger than their instruments could detect. Perhaps most astonishing is how these ideas were preserved, not in dry equations, but in vibrant myths. The god Vishnu sleeps on the serpent Ananta, whose coils symbolize infinite time, while his dreams spawn countless universes. It's a breathtaking metaphor for the multiverse theory, where bubble universes constantly form in an ever-expanding cosmic ocean. Even their sacred syllable, resonates with modern cosmology, sound vibrations creating form, much like how quantum fluctuations seeded galaxies. What makes Vedic astronomy so extraordinary isn't just its accuracy, but its audacity. Without telescopes or particle accelerators, these ancient scholars dared to imagine realities we're still verifying today. They saw the cosmos not as a cold machine, but as a living, breathing entity, a perspective some cutting-edge physicists are now revisiting. Maybe that's the real lesson here. When science and wonder walk hand in hand, even the wildest myths can point to profound truths. The Maya didn't just watch the sky, they spoke its language. While Europe languished in the Dark Ages, Mayan astronomers were calculating Venus's 584-day cycle with an error margin of just 2 hours. Their Dresden Codex, a bark paper book folded like an accordion, isn't just a relic, it's a precision astronomical almanac, tracking the movements of planets with math so advanced it baffled scholars for centuries. But here's what's truly extraordinary. They didn't separate science from story. To them, Venus wasn't merely a planet. It was Kukulkan, the feathered serpent slithering across the heavens, its appearances and disappearances dictating when to wage war or plant crops. Then there's the mystery of the smoking star. In the year 1054, Chinese and Arab astronomers recorded a sudden brilliance in the daytime sky, a supernova so bright it cast shadows for weeks. Half a world away, with no telescopes or written records, the Maya seem to have witnessed it too. Their myth of a god hurling a fiery cigar into the heavens matches the Crab Nebula's violent birth with uncanny accuracy. This wasn't just folklore, it was celestial journalism, preserving a cosmic event in the only vocabulary they had. But the Maya's genius didn't stop at observation. Their long count calendar, often misrepresented as a doomsday clock, was actually a masterwork of cosmic synchronization. It meshed solar years, lunar months, and Venus cycles into a unified system so precise it could pinpoint celestial events thousands of years in the future. Their temples weren't just places of worship, they were astronomical instruments. El Castillo at Chichen Itza, for example, casts a serpent-shaped shadow during equinoxes, a stone embodiment of Kukulkan descending to Earth. What's haunting is how their myths encoded warnings. The Popol Vuh tells of heroes venturing into the underworld, where the lords of death test them with impossible trials. Read metaphorically, it's a blueprint for navigating cosmic cycles. The underworld representing Venus's invisible period behind the sun, a time of uncertainty before its triumphant reappearance as the morning star. Even their ball game, with its rubber sphere symbolizing the sun's movement, mirrored orbital mechanics. The Maya remind us that science and myth were once the same discipline, two sides of a single coin minted from wonder and rigor. They tracked the stars not to demystify the cosmos, but to converse with it. In their world, a supernova wasn't just an explosion, it was a divine omen. A planet wasn't a rock, it was a god keeping time, and perhaps that's their most profound lesson. The universe doesn't just compute, it communicates. We've traded their stories for equations, but the dialogue never really ended. The sky still speaks if we're willing to listen. For the Aboriginal peoples of Australia, the night sky wasn't just a spectacle, it was a living library. Its stories whispered across 65,000 years. Take the emu in the sky, a constellation not of stars, but of the dark spaces between them. Where others saw emptiness, Aboriginal astronomers recognized shapes in the Milky Way's dust clouds, a celestial emu whose position signaled the perfect time to gather eggs. But here's what's astonishing. Modern astrophysics reveals those dark patches aren't just voids. They're interstellar dust clouds, the very material that shapes galaxies, and a hint of the invisible dark matter weaving the cosmos together. It's as if these ancient storytellers mapped the unseen scaffolding of the universe long before science had the tools to prove it. Their knowledge went far beyond constellations. Oral traditions meticulously documented the rhythms of the tides, linked to the moon's phases, and tracked the erratic pulse of Betelgeuse, a star whose brightness fluctuates over centuries. How could a culture without written records preserve such precise astronomical data? The answer lies in the rigor of their storytelling. Songs, dances, and paintings weren't just art. They were mnemonic devices, encoding complex information in rhythms and symbols designed to survive generations. When elders sang of the seven sisters fleeing across the sky, they weren't just recounting a myth. They were teaching the movement of the Pleiades star cluster, its seasonal shifts critical for navigation and harvest. What's even more striking is how these stories align with modern discoveries. The Dreamtime narrative of the Milky Way as a river of stars mirrors our understanding of galaxies as flowing structures bound by gravity. Their tales of ancestral beings shaping the land echo the slow, cosmic forces that sculpt planetary surfaces over eons, and their concept of song lines, paths across the land and sky traced through music uncannily parallels today's theories about vibrational patterns underlying the fabric of spacetime. This wasn't mere coincidence. Aboriginal elders spoke of fresh and saltwater meeting in the sky, a poetic description of the Magellanic Clouds, two dwarf galaxies orbiting our own. Recent studies confirm these galaxies are indeed rich in both young, fresh stars and older, saltwater stellar populations. Their stories even warned of fire stars that could vanish, a possible reference to supernova fading from view. The genius of these traditions lies in their duality. They were both cultural touchstones and scientific records, blending observation with meaning. Where Western science separates data from dogma, Aboriginal knowledge reminds us that understanding the cosmos isn't just about measuring it, it's about belonging to it. Their emu in the sky isn't just a guide to the seasons, it's a testament to humanity's oldest truth. The universe speaks in patterns, and myth is perhaps our first language for deciphering them. In the court of ancient China, astronomers weren't just stargazers, they were cosmic bureaucrats, meticulously documenting celestial movements as if taking minutes for the universe itself. The night sky mirrored their imperial hierarchy, with the North Star serving as the unmoving celestial emperor, surrounded by constellations representing his ministers, palaces, and even an astronomical prison for wayward stars. But beneath this poetic cosmology lay a scientific precision that would leave modern researchers stunned. The Dunhuang star maps, painted on silk over 1,000 years ago, charted over 1,300 stars with such accuracy that they've helped identify the remnants of ancient supernova, including the famous Crab Nebula's explosion in the year 1054. These weren't just pretty pictures, they were functional databases encoding celestial patterns with bureaucratic efficiency. Consider the timeless myth of the Weaver Girl and the Cowherd, represented by the stars Vega and Altair. Separated by the silvery band of the Milky Way, they are permitted to meet just once a year, a story celebrated during the Kixi festival. On the surface, it's a tender romance, but look deeper. The tale encodes an astronomical reality. The celestial river dividing them isn't arbitrary. It follows the galactic plane's dense star fields, invisible to the naked eye yet intuited by ancient observers. Even their annual reunion corresponds with the 7th lunar month, when these stars align visibly in the night sky. This wasn't mere storytelling, it was celestial cartography disguised as folklore. The Chinese took this harmony between myth and measurement even further with their celestial clockwork. The 28 mansions system divided the sky into lunar lodges, each corresponding to specific constellations that track the moon's monthly journey. But here's the twist: these divisions weren't just symbolic. They functioned as a precision calendar, guiding agricultural cycles and imperial ceremonies with uncanny reliability. When they described the azure dragon of the east or the black tortoise of the north, they weren't just painting pictures, they were mapping seasonal asterisms, their mythical creatures serving as mnemonic devices for tracking Jupiter's 12-year orbit or predicting solar eclipses. Perhaps most astonishing was their understanding of cosmic unpredictability. While they envisioned heaven as orderly, they also kept detailed records of guest stars, sudden bright visitors we now know as supernova and comets. The bamboo annals, dating back over 2,600 years, note a five-tailed star that appeared and vanished, likely Halley's Comet, making its regular pilgrimage. Their meticulous logs of such events weren't just historical curiosities, they've become invaluable to modern astronomers studying stellar evolution. What emerges is a civilization that refused to separate poetry from precision. Their constellations weren't just shapes but characters in a celestial drama, one that somehow managed to be both scientifically rigorous and deeply human. The stars were ministers filing reports to the celestial emperor, lovers kept apart by galactic tides, omens written in light. In their vision, the cosmos wasn't a cold machine but a vast, intricate bureaucracy, one where every flicker and movement carried meaning, if you knew how to read the sky's meticulous paperwork. To the ancient Egyptians, the Milky Way wasn't just a streak of light. It was the celestial twin of their life-giving Nile, a shimmering highway where gods and souls sailed among the stars. They called it the winding waterway, and just as the Nile's annual floods nourished their fields, this heavenly river was thought to overflow with divine energy, feeding the cosmos itself. But here's what's truly remarkable. Modern astronomers have discovered that our galaxy does indeed contain vast rivers of gas and star-forming material, flowing through space like cosmic tributaries. The Egyptians, gazing up with unaided eyes, somehow grasped the Milky Way's dynamic nature centuries before science confirmed it. Their pyramids weren't just tombs, they were celestial time machines. The narrow shafts piercing the Great Pyramid's core align with uncanny precision to Orion's belt and the pole star Thuban, which held that position in 2500 BC. This wasn't random stargazing, it was sacred architecture designed to bridge earth and sky. When a pharaoh died, the Egyptians believed his soul would ascend these shafts like a ladder, joining Osiris among the stars. Today, we see their vision reflected in infrared telescopes revealing how newborn stars ascend along filaments of cosmic dust, vertical pathways eerily reminiscent of those pyramid shafts. Then there's the sun god Ra, whose nightly voyage through the Duat, the starlit underworld, wasn't just mythology. Modern simulations show our solar system bobbing like a boat on the Milky Way's dark matter halo, completing one galactic orbit every 230 million years. The 12 hours of Ra's perilous journey past serpent gods and flaming lakes, they mirror the sun's passage through different galactic regions, from star-forming nebulae to the voids between spiral arms. Even their Book of Gates, detailing the sun's obstacles, aligns with known hazards like interstellar gas clouds and rogue black holes. But the real genius lay in how they merged measurement with meaning. The cubit, their standard unit of length, was tied to Earth's circumference, while temple layouts encoded the ratios of planetary orbits. At Dendera, the zodiac ceiling doesn't just depict constellations, it's a functional star clock. Its images arranged to track precession, the slow wobble of Earth's axis. They even understood light-year scales intuitively. Their texts described the sky as iron bones holding up the stars, a poetic nod to the invisible magnetic fields shaping our galaxy. What makes Egyptian cosmology so extraordinary is its dual nature. They saw the universe as both a divine story and a mathematical puzzle, where every myth concealed an observation, every ritual a calculation. When they painted Nut, the sky goddess, arched over Geb, the earth god, they weren't just illustrating a creation myth. They were mapping the curvature of space-time itself, long before Einstein's equations gave it a name. Their genius wasn't in separating science from spirituality, but in realizing the cosmos speaks both languages at once. Imagine setting sail across thousands of miles of open ocean with no compass, no maps, just the stars above, the waves below, and the flight patterns of birds as your guide. This wasn't just a feat of courage for the Polynesians. It was a science so refined it feels almost supernatural. Their navigators, or wayfinders, didn't just memorize star positions. They internalized the ocean's pulse, reading subtle shifts in swells, cloud formations, and even the phosphorescent glow of underwater life. A flicker of distant bird flight could signal land over the horizon, while the taste of salt spray carried clues about currents unseen. What's astonishing isn't just their accuracy, it's how their understanding of the sea's rhythms echoes modern physics' most mind-bending concepts. Take their creation myth of Taroa, the cosmic deity who shaped the universe from a primordial shell. In the beginning, there was only Tumu, the source, a void that crackled with potential. Sound familiar? It's a striking parallel to quantum foam, the seething substrate of space-time where particles blink in and out of existence. The Polynesians envisioned creation as an unfolding tapestry of interconnected forces, much like today's theories of quantum entanglement, where particles remain mysteriously linked across vast distances. Their navigators didn't just sail, they danced with these invisible threads, sensing connections between stars, waves, and wind that science is only now beginning to quantify. Modern researchers are obsessed with Polynesian wayfinding because it reveals something extraordinary: the human brain's ability to process multidimensional space intuitively. When a wayfinder charts a course by feeling the interplay of swell directions, primary, secondary, even tertiary waves, they're essentially navigating a hidden lattice of energy, not unlike how physicists map quantum fields. Their star compass, or Cape Huwetu, didn't just point north, it encoded a four-dimensional mental model of Earth's rotation, celestial motion, and seasonal variations. Neuroscientists now study these techniques to develop AI that can navigate chaotic environments, proof that ancient knowledge can revolutionize future tech. The real magic lies in how they merged myth with precision. The demigod Maui fishing up islands from the deep wasn't just a story, it was a metaphor for volcanic hotspots birthing landmasses along tectonic seams. Their oral traditions preserved tidal data across generations with chants so rhythmically precise, they functioned as living algorithms. Even their concept of mana, the spiritual energy flowing through all things, resonates with modern physics' hunt for dark energy, the unseen force accelerating the universe's expansion. Polynesian navigation wasn't just about reaching a destination, It was a dialogue with the cosmos. Their wayfinders didn't conquer the ocean. They listened to it, learning its language well enough to hear islands singing on the horizon. In an age where GPS satellites orbit overhead, their legacy whispers a profound truth. Sometimes, the oldest maps are written not on paper, but in the stories we tell about the stars. Medieval alchemists hunched over their crucibles weren't just chasing fairy tales, they were pioneering chemists speaking in code. When they scribbled dragons devouring their own tales in ancient manuscripts, they weren't doodling fantasy, they were sketching the very processes that power stars. That serpent swallowing itself, the Ouroboros, wasn't just a mystical symbol, it was their way of describing cyclical transformation, the endless consumption and rebirth of matter. Today, we recognize that same pattern in the heart of our sun, where hydrogen atoms fuse into helium in a self-sustaining loop, matter constantly recreating itself. The alchemists just didn't have the words we do, so they spoke in flames and fantastical beasts. Take their obsession with the philosopher's stone, that mythical substance said to transmute base metals into gold. While they never found it, their experiments unlocked something far more valuable, the realization that matter could change its nature entirely. Every time they heated mercury or dissolved metals in acid, they were witnessing what we now call chemical reactions, elements reorganizing at their core. Their cryptic illustrations of lions eating the sun or eagles ascending weren't just arcane art, they were lab notes in disguise. A red lion might symbolize iron oxide, while a green dragon could represent sulfuric acid. These weren't arbitrary codes, they were survival tactics in an era when revealing too much could mean persecution. But here's where it gets truly fascinating. Modern particle physics echoes their most poetic metaphors. When alchemists wrote of the prima materia, the formless essence underlying all matter, they were groping toward the concept of atomic energy. Their visions of purification through fire mirror how stars forge heavy elements in supernova explosions. Even their 7 metals linked to the 7 classical planets uncannily align with the sequence of elements in the periodic table, from silver's conductivity to gold's resistance to corrosion. What we once dismissed as superstition was actually proto-science wrestling with forces too vast to name. The phoenix rising from ashes, that's oxidation and reduction in chemical cycles. The wedding of the sun and moon, an early grasp of polarity and electron exchange. These weren't failed scientists, they were pioneers working without a map, using the only language they had to describe a universe far stranger than their tools could measure. So next time you see an ancient alchemical text filled with winged serpents and celestial marriages, don't just see mysticism, see the birth pangs of chemistry. The moment humanity began to realize that the secrets of the cosmos weren't locked in divine scrolls, but hidden in the very stuff of the world waiting for the right symbols to set them free. The Aztecs didn't just worship the sun, they understood its terrifying fragility. Their myth of the fifth sun begins with a chilling prophecy. 4 previous worlds had already been annihilated, each collapsing under cosmic catastrophes. The first era ended when jaguars devoured humanity, the second in hurricanes, the third in fiery rain, and the fourth in floods. At first glance, these sound like archetypal doomsday tales until you realize they mirror Earth's actual mass extinctions with eerie precision. The jaguars, possibly the asteroid that wiped out the dinosaurs. The floods, global sea level rises from ancient ice ages. The Aztecs weren't just spinning stories, they were preserving ancestral memories of planetary upheaval encoded in myth. But their vision went deeper. The fifth sun, Tenatia, demanded a gruesome price to keep moving across the sky. Human hearts offered daily. This wasn't mere bloodlust, it was a profound metaphor for how stars actually work. Modern astrophysics reveals that our sun, like all stars, is a cosmic alchemist, fusing hydrogen into helium in its core. Every second, it sacrifices millions of tons of mass as energy to sustain its light, a process called nucleosynthesis. The Aztecs ritualized this violent truth, portraying the sun as a deity hungering for vitality to postpone its inevitable death. Their priests performing heart extractions atop pyramids were, in a twisted way, reenacting the sun's own self-consumption. Then there's the sunstone, that colossal carved disk often mistaken for a simple calendar. Look closer, and you'll discover a fractal masterpiece of cosmic timekeeping. Its concentric rings don't just count days, they map nested cycles, from the 260-day sacred round to the 52-year century when their calendar reset. This layered view of time mirrors modern cosmology's understanding of the universe as a series of unfolding epochs, from quark soups to galaxy formation. Even the stone's central face, depicting Tanatia with a clawed tongue, holds a secret. It's surrounded by 4 square panels representing the previous destroyed suns, a graphic timeline of cosmic evolution. What's truly mind-bending is how their myths anticipated cyclical universe theories. The Aztecs believed the 5th sun would eventually perish in earthquakes, completing the sequence before a 6th world emerged. Today, some physicists speculate our universe might follow a similar pattern, expanding, contracting, and rebounding in endless Big Bangs. The sunstone's spiraling designs even resemble contemporary diagrams of cosmic inflation, where space-time stretches like woven fabric. The Aztecs' genius lay in their fusion of brutality and brilliance. Their pyramids weren't just temples, they were observatories aligned to solstices, their sacrifices timed to celestial events. When they painted the dawn sky as a battlefield where the sun triumphed over stars each morning, they were poetically describing light scattering through the atmosphere. Their vision of the cosmos as both sacred and sacrificial reminds us that every sunrise comes with a price, a truth written not just in their myths, but in the nuclear fires of every star. Stories of celestial dragons breathing fire across the heavens appear in cultures separated by oceans and millennia. But what if these weren't just flights of fantasy? Modern plasma physicists point to something startling. The sinuous, twisting forms of dragons bear an uncanny resemblance to the filaments of magnetized plasma writhing through space. When Chinese astronomers recorded sky serpents with glowing scales, they might have been witnessing the same phenomena we now photograph in nebulas and auroras, superheated gas sculpted by electromagnetic forces into living shapes. The link becomes even clearer when you examine medieval European accounts of dragons spewing venomous vapors that poisoned the air. Today, we recognize these descriptions as eerily accurate depictions of plasma discharges, ionized gas streams that can indeed produce toxic ozone when they interact with Earth's atmosphere. The Norse spoke of the Midgard serpent coiling around the world. Plasma cosmology suggests they might have been intuiting the heliospheric current sheet, a vast ripple of charged particles spiraling out from our sun. Even the dragon's traditional association with hoarding gold takes on new meaning when you consider how plasma filaments in space concentrate heavy metals like cosmic prospectors. Perhaps most compelling are the ancient petroglyphs found from Arizona to the Kazakh steppes, depicting serpentine figures surrounded by radiating lines. Plasma physicist Anthony Perrat identified these as near-perfect matches for high-energy plasma instabilities patterns that only form during intense solar storms or auroral events. Indigenous oral traditions describe these sky serpents appearing during times of celestial upheaval, their twisting bodies foretelling droughts or migrations. It's as if our ancestors were documenting real plasma phenomena through the only lens they had: mythic storytelling. What makes plasma cosmology so tantalizing isn't just these visual parallels, it's the behavior. Dragons in legends don't just slither, they bifurcate, merge, and explode in bursts of light, mirroring how plasma filaments twist and reconnect in space. Chinese astronomers wrote of dragons fighting in the sky before vanishing in flashes, a dead ringer for magnetic reconnection events, where snapping field lines release staggering energy. The Babylonian Tiamat, sliced in two by Marduk to form heaven and earth, that could be a poetic description of plasma pinch effects, where currents collapse a filament into distinct regions. This isn't to say ancient people understood plasma physics, but their myths suggest they observed its effects with startling clarity. Without the concept of ionization, they interpreted these phenomena as living creatures: the Chinese azure dragon controlling storms, the Slavic zime breathing lightning, the Aboriginal rainbow serpent carving rivers of energy across the sky. Today, we've traded scales and wings for terms like Birkeland currents and Z-pinches, but the essence remains: a recognition that the cosmos thrums with invisible forces that sometimes spectacularly reveal themselves in serpentine fire. Deep in the cliffs of Mali's Bandiagara escarpment, the Dogon people have preserved astronomical knowledge that defies simple explanation. Their oral traditions speak of Sirius not as a single star, but as a system centered around what they call Potolo, an impossibly dense companion star. This wasn't just poetic metaphor. Modern telescopes later revealed Sirius B, a white dwarf so faint and small, its existence wasn't confirmed until the 19th century. Yet Dogon elders described its elliptical orbit and staggering density centuries earlier, calling it the smallest thing there is, made of a metal heavier than iron. How could a culture without optical instruments know about a star invisible to the naked eye? The mystery deepens when you examine their other celestial insights. Dogon cosmology includes precise descriptions of Saturn's rings, which they liken to spinning halos of dust, and Jupiter's 4 largest moons, calling them the planet's children. These weren't vague references. Their myths specified numbers and arrangements that match what Galileo first saw through his telescope in 1610. Even more striking is their understanding of the moon's barren nature, referring to it as dry and dead like a cinder, long before Apollo missions proved its lack of atmosphere. Skeptics argue these details could have been introduced by Western visitors in the 1900s, pointing to anthropologists like Marcel Grioul, who studied the Dogon in the 1930s. But here's what's often overlooked. Dogon astronomical knowledge was already woven into rituals, artifacts, and sand diagrams predating European contact. Their Sigui ceremony, held every 60 years to mark Sirius A and B's orbital alignment, involves masks carved with precise celestial geometry, some dating back to the 15th century. That's 300 years before astronomers calculated Sirius B's exact orbital period. Perhaps the most compelling detail lies in their description of a third star in the Sirius system, a hypothetical Sirius C that astronomers have hunted for decades. In 1995, French researchers claimed to detect gravitational perturbations suggesting its existence, though conclusive proof remains elusive. Yet Dogon oral tradition already speaks of Emya, a smaller companion to Potolo, orbiting even farther out. Whether this is extraordinary intuition or preserved knowledge from an unknown source, it challenges our assumptions about how scientific discovery unfolds. What makes the Dogon legacy so fascinating isn't just the accuracy of their astronomy, it's the way their knowledge was structured. Unlike Western science, which isolates facts from meaning, their cosmology blends observation with philosophy. Sirius B wasn't just a star, it represented the seed of creation, a compact source from which all things emerged. Their understanding of cosmic cycles wasn't merely calendrical, it was tied to agricultural rhythms, social structures, and spiritual renewal. This holistic approach mirrors modern systems theory, where celestial mechanics and earthly processes are seen as interconnected. The Dogon remind us that the line between myth and science has always been porous. Whether their knowledge came from ancient starfaring visitors, as some speculate, or from generations of meticulous sky watching refined over millennia, their stories force us to reconsider what discovery really means. Sometimes truth doesn't wait for telescopes, it travels through time in the whispers of oral tradition, waiting for the moment when science finally catches up to the wisdom of the elders. Genesis paints a striking picture of creation, a vast expanse called the firmament stretched like a dome, separating celestial waters above from earthly waters below. At first glance, it seems like primitive cosmology until you compare it to cutting-edge astrophysics. What if that ancient description wasn't just poetic metaphor, but an uncanny intuition about the universe's hidden architecture? Modern telescopes reveal the cosmic web, a sprawling network of filaments made of dark matter and gas, threading through the void like divine scaffolding. These tendrils, some stretching hundreds of millions of light-years, literally separate regions of sparse intergalactic waters from dense galaxy clusters. The resemblance is startling. Both visions depict a structured divide between different cosmic realms. This parallel becomes even more compelling when you consider how the cosmic web functions. Those dark matter filaments aren't just decoration, they're the universe's circulatory system, channeling gas into galaxies like rivers feeding a delta. The Book of Job describes the firmament as hard as a molten mirror, which eerily echoes how plasma physicists characterize the magnetic fields braided through cosmic filaments. Even the waters above find a modern counterpart in the WIM, the warm, hot intergalactic medium, a mist of superheated gas clinging to the web's strands. It's as if biblical authors glimpsed the universe's underlying blueprint, translating it through the imagery of their time. Theological scholars are divided on how to interpret this overlap. Some argue it's evidence of divine revelation, a kernel of supernatural truth embedded in Scripture. Others see it as humanity's innate pattern, seeking our ancestors observing nature's repetitions, from branching rivers to veins in leaves, and projecting that order onto the cosmos. But there's a third possibility, that these myths preserve fragments of lost knowledge. Ancient Mesopotamian texts like the Enuma Elish also describe a layered cosmos with celestial waters, suggesting this was a widespread cosmological model. Could it have stemmed from meticulous observation of atmospheric halos, eclipses, or even plasma phenomena visible during rare solar storms? What makes the firmament idea so fascinating isn't just its accidental accuracy, it's the way it challenges our assumptions about progress. We assume knowledge moves linearly from myth to science, but sometimes the arrow points both ways. When researchers first simulated the cosmic web structure in the 1990s, they were stunned by its resemblance to neural networks in the human brain. Suddenly, age-old metaphors comparing the heavens to a mind of God took on new scientific weight. The universe's largest-scale structure does mirror a kind of cosmic consciousness, billions of galaxies firing along dark matter synapses. Perhaps the deepest lesson here is about language itself. The authors of Genesis lacked terms like baryonic matter or zoo of galaxies, so they spoke of waters and vaults. Today, we've traded those symbols for equations and supercomputer models, but the essential wonder remains. Whether you read the firmament as theology or proto-science, it reminds us that every culture grapples with the same majestic mysteries. We just dress them in different words. And sometimes, across the chasm of millennia, those words whisper to each other. Siberian shamans didn't just tell stories, they embarked on voyages. Cloaked in reindeer hides and drumming rhythmic pulses, they spoke of leaving their bodies behind, riding antlered steeds across the night sky to converse with star spirits. At first glance, it's easy to dismiss these accounts as hallucinatory visions until you place them beside modern lab experiments on astral projection. Volunteers in controlled studies describe eerily similar experiences, floating above their physical forms, traversing vast distances instantaneously, even encountering luminous beings. What's astonishing isn't just the overlap, it's that neuroscience now confirms these states aren't mere fantasy. Brain scans of shamanic trances reveal heightened activity in the temporoparietal junction, the same region that glows when test subjects report out-of-body experiences. It's as if these ancient practitioners discovered a backdoor in human consciousness, one that science is still learning to map. Consider the Evenk people's belief that the Milky Way was a trail of frozen hoofprints from celestial reindeer. This wasn't just poetic imagery, it encoded a sophisticated understanding of altered states. Their shamans used drumbeats tuned to 4 to 7 Hz, frequencies now known to induce theta brainwaves, the same trance-like state associated with deep meditation and vivid mental journeys. When they described bridges of light connecting worlds, modern physics offers a provocative parallel: quantum entanglement, where particles remain mysteriously linked across space. The shaman's journeys might have been early intuitions about non-local consciousness, the idea that mind isn't confined to the brain, but interwoven with the fabric of reality itself. Laboratory studies add another layer to this mystery. Researchers at the University of Kentucky found that volunteers deprived of sensory input, much like shamans in darkened tents, began reporting out-of-body experiences within hours. Their brains, starved of external stimuli, started generating vivid internal landscapes indistinguishable from real perception. This suggests shamanic flight might not be supernatural, but a natural capacity of the human mind, one our ancestors cultivated through ritual while we've largely forgotten it. Even the reindeer themselves hold a clue. Siberian herds consume hallucinogenic mushrooms, which shamans also used ceremonially. But here's the twist: these substances don't just cause hallucinations, they temporarily dissolve the brain's default mode network, the mental filter that convinces us we're separate from our surroundings. What emerges is a radical possibility. These myths weren't just explanations of the cosmos, but manuals for exploring it firsthand. When a shaman spoke of riding starlight to distant galaxies, they might have been describing a genuine perceptual shift, one where consciousness, freed from the body's constraints, could interface with the universe in ways we're only beginning to understand. Modern experiments with sensory deprivation tanks and virtual reality show how easily our brains can be convinced they're elsewhere. The shamans didn't need technology. They hacked their own neurology through rhythm, ritual, and generations of accumulated wisdom. This isn't about proving whether astral projection is real in a material sense. It's about recognizing that our ancestors may have developed a science of inner space long before we mastered outer space. Their star roads and spirit animals could be maps of neural pathways, their celestial reindeer vehicles for navigating the mind's uncharted territories. As quantum physicists grapple with the role of observation in shaping reality, the shaman's legacy whispers a provocative question: what if the cosmos isn't something we're separate from, but something we're in constant, conscious dialogue with? Their myths remind us that every journey to the stars begins not with a rocket, but with a shift in perception. The Babylonians first mapped the zodiac as a practical tool, a celestial calendar dividing the sky into 12 slices. each marking the sun's monthly position. But over centuries, these star groups transformed into something far more profound, a mirror held up to human nature itself. Consider Aries, the ram charging headfirst into battle. At first glance, it's just a constellation until you recognize its uncanny alignment with spring's explosive energy, when plants burst through soil and animals emerge from hibernation, driven by the same impulsive vitality. Or Libra, the scales perfectly balanced at autumn's equinox, when day and night hang in temporary harmony, a cosmic metaphor for humanity's eternal struggle to find equilibrium in a chaotic world. Carl Jung saw these patterns not as ancient superstition, but as a psychological Rosetta Stone. He believed the zodiac symbols were archetypes, universal blueprints buried deep in our collective unconscious. The Scorpio's transformative sting mirrors every human's capacity for reinvention after crisis. The Piscean fish swimming in opposite directions captures our dual longing for connection and solitude. These weren't just stories told about the stars, they were stories the stars told about us, encoded in light across millennia. What's startling is how modern research lends unexpected weight to these ideas. A 2018 study analyzing over 10 million social media posts found linguistic shifts correlating with planetary positions, people expressing more competitive language during Mars transits, more reflective tones under Neptune's influence. Another project tracking hospital admissions discovered slight but statistically significant spikes in births during full moons, echoing the ancient link between lunar cycles and fertility goddesses. Even farmers observing planting rhythms tied to zodiac phases report higher crop yields, though science hasn't fully explained why. This isn't about astrology's mystical claims, it's about recognizing how myths might encode subtle environmental wisdom. Before artificial lights drowned out the night sky, humans lived bathed in celestial rhythms. The Babylonians noticed how certain star patterns coincided with seasonal floods or migratory patterns. Over generations, these observations crystallized into symbolic narratives, a way to pass down survival knowledge through stories. Taurus the bull didn't just represent stubbornness, it marked the season to yoke oxen for plowing. Virgo's wheat sheaf signaled harvest time. The zodiac's real power lies in its duality. It's both a star map and a soul map. When medieval alchemists aligned their experiments with planetary hours, they weren't just following tradition. They were acknowledging the universe as an interconnected system, where microcosm and macrocosm reflect each other. Modern quantum physics hints at similar entanglement, the idea that particles once connected remain mysteriously linked across distance, like celestial bodies whispering to the molecules in our cells. Perhaps the ancients sensed this hidden dialogue, translating it into symbols that still resonate because they speak a primordial truth. We're not just observers of the cosmos, but participants in its grand, unfolding story. Plato's tale of Atlantis sinking beneath the waves isn't just a story, it's a warning etched in myth. He described a dazzling island empire with towers clad in orichalcum, a metal that gleamed like fire, and canals that mirrored the paths of stars. Their downfall, a single night of earthquakes and floods erasing their glory beneath the sea. But what if this legend isn't just about a lost city, but about lost knowledge? The Minoans, a real Bronze Age civilization on Crete, built palaces aligned with solstices and painted frescoes of celestial bulls leaping through star fields. When their cities were swallowed by volcanic eruptions around 1600 BC, their understanding of the heavens may have vanished with them, leaving only fragments that resurface in myths like Atlantis. The eerie parallels don't stop there. Plato claimed Atlanteans worshipped the god Poseidon, who gifted them sacred geometry and celestial maps. Dig into Minoan ruins, and you'll find altars to a trident-wielding sea deity, alongside artifacts suggesting they tracked Venus's 8-year cycle, critical for navigation. Their sudden collapse echoes Atlantis' fate, as if Plato preserved a distorted memory of a culture whose astronomical prowess was literally buried under ash. Even the name Atlantis might hold a clue. Some scholars link it to the Minoan word Atlas, meaning to bear or endure, hinting at a people who carried sky knowledge across generations until disaster struck. This taps into something primal, the terror of cultural amnesia. Every time archaeologists uncover an ancient observatory like Greece's Antikythera mechanism or Cambodia's Angkor Wat temple's structures encoding precise astronomical data, we're reminded how easily knowledge can evaporate. The Maya star tables were nearly lost to Spanish bonfires. Babylonian eclipse records molded in desert ruins for millennia. Atlantis embodies our dread that tomorrow's civilizations might one day puzzle over our Hubble images, wondering how we knew so much yet left so little behind. Yet the myth also sparks hope. Modern deep-sea explorers have found sunken cities like Egypt's Heracleion and India's Dwarka, proving civilizations do vanish beneath waves and sometimes resurface. When sonar revealed geometric structures off Cuba's coast or Japan's Yonaguni monument, Atlantis fever reignited. These discoveries, even when debunked, reveal our longing to recover what was lost, to find a Rosetta Stone that might crack open forgotten cosmic wisdom. Perhaps Atlantis's greatest lesson isn't about the past but the future. As climate change threatens coastal cities today, Plato's allegory feels unnervingly prescient. The Minoan's fate warns that even advanced societies are fragile, while their surviving star lore like the constellation Taurus, which their bull-leaping rituals may have celebrated, proves ideas can outlast empires. Atlantis endures because it's more than a sunken city. It's a mirror reflecting our own fears of collapse and our stubborn faith that somewhere, in ruins or reefs or ancient texts, the stars still keep their oldest secrets. Mercury darts across the sky like a thief in the night, swift, unpredictable, impossible to pin down. The Romans knew this when they named the planet after their trickster god, the quick-footed Mercury, while the Greeks called him Hermes, the divine messenger whose winged sandals carried him between worlds in the blink of an eye. What's astonishing isn't just how well these myths captured Mercury's visible behavior, it's how they eerily foreshadowed the planet's deepest scientific secrets. Ancient stargazers noticed Mercury's strange dance. While other planets moved in stately, predictable orbits, this one zigzagged, sometimes appearing in the morning, other times vanishing into the sunset within days. They saw a cosmic rule breaker, and they were right in ways they couldn't possibly have imagined. Centuries later, Newton's laws of motion should have explained Mercury's path, but something was off. No matter how precisely astronomers calculated, the planet's orbit didn't quite fit. It was as if Mercury had a secret, slipping through the cracks of physics like Hermes slipping past Apollo's watchful gaze. The discrepancy was small, just 43 arcseconds per century, but it was enough to unravel classical mechanics. Then came Einstein in 1915, revealing that Mercury wasn't breaking the rules at all. It was playing by deeper ones, the curved spacetime near the sun, where gravity warps the very fabric of reality. That tiny orbital wobble wasn't an error, it was the first whisper of relativity, a truth hidden in plain sight since antiquity. The parallels between myth and science don't stop there. Hermes wasn't just fast, he was a boundary crosser, moving freely between the mortal world, the heavens, and even the underworld. Mercury, the planet, does something strikingly similar. Its eccentric orbit takes it swinging from the sun's blistering doorstep out to the cooler edges of the inner solar system, a cosmic pendulum with no true counterpart. Modern probes like NAS, a messenger, have revealed even more quirks. a core so massive it makes up nearly 85% of the planet's radius, as if Hermes hid a heavy secret under his lightweight exterior. The planet's surface is scarred with ghostly hollows pits that seem to evaporate into space, mirroring the god's elusive nature. Perhaps most poetic is Mercury's spin-orbit resonance. For every 2 trips around the Sun, it rotates exactly 3 times a celestial dance step so precise it feels like divine choreography. This rhythm means a day on Mercury lasts 2 of its years, a paradox that would have delighted the trickster god himself. Even the planet's extremes echo Hermes' duality: days hot enough to melt lead, nights cold enough to freeze oxygen solid, and a twilight zone where both realities coexist. What's mesmerizing here isn't just that the ancients personified Mercury's oddities, it's that their myths preserved intuitive truths about its nature long before telescopes or tensor calculus. They couldn't calculate general relativity, but they sensed this world operated by different rules. When they depicted Hermes as a thief outsmarting the gods, they might as well have been describing Mercury's gravity-defying orbit, stealing momentum from the Sun's grip. Science has since given us the equations, but the mystery remains. How did myth so often glimpse truths that took millennia to prove? Maybe the stars have always been speaking, not in numbers but in stories, waiting for us to learn their language. Moon goddesses have watched over humanity's dreams since the first stories were told. Artemis, the Greek huntress who chased silver stags across the night sky, wasn't just a deity, she embodied the moon's dual nature, radiant yet untouchable, nurturing yet fiercely independent. Half a world away, China's Chang floated in her lunar palace with a jade rabbit, weaving tales of immortality that would one day inspire a nation's space ambitions. What's mesmerizing isn't just the universality of these myths, it's how often they linked the moon to fertility long before science confirmed its pull on life itself. Coastal cultures from the Pacific to the Mediterranean noticed shellfish spawning in sync with high tides, women's cycles mirroring lunar phases, even crops seeming to thrive under certain moonlights. Modern studies reveal these aren't mere folklore. Lunar gravity's subtle tug does influence circadian rhythms in marine life, while some research suggests birth rates may slightly peak around the full moon. The goddesses knew what science would take millennia to prove. The moon doesn't just light our nights, it orchestrates them. Now, those same myths are taking on startling new relevance. When robotic explorers discovered vast lava tubes beneath the moon's surface caves, shielded from radiation and temperature extremes, they unwittingly revived ancient visions of lunar dwellings. Chang's celestial palace suddenly seems less like fantasy and more like a blueprint. The Artemis program, named deliberately after that same arrow-slinging goddess, aims to land astronauts near these very caves by 2025, turning myth into infrastructure. Even the Maya moon goddess Ixchel, often depicted with a rabbit, a creature that coincidentally became the mascot for China's lunar rover, feels eerily prescient. These goddesses weren't just storytellers, they were humanity's first lunar architects, their legends sketching out habitats we're only now learning to build. The deeper connection lies in the moon's rhythm. Artemis governed not just hunting but childbirth, her silver light a beacon for new life. Today, that same rhythm could sustain life off-world. Lunar caves maintain a stable temperature around -20 degrees Celsius, harsh by Earth standards, but paradise compared to the surface's 300-degree swings. Their ceilings, thick with volcanic rock, block 80% of cosmic radiation, creating natural sanctuaries perfect for future bases. It's as if the goddesses left us a cosmic cheat sheet. Follow the tides to sheltered wombs beneath the surface, just as their myths once guided ancient midwives. What's poetic is how these stories are coming full circle. China's Chang missions, named directly after their moon goddess, have already grown lunar plants in sealed biospheres, their tender shoots echoing the fertility myths of old. Meanwhile, NASA Artemis program explicitly aims to land the first woman on the moon, intertwining ancient symbolism with modern equality. The moon's caves may soon hum with hydroponic gardens and recycled air systems, but their essence will remain unchanged, sanctuaries of renewal, just as the goddesses promised. This isn't coincidence, it's cultural memory encoded in starlight. When astronauts someday cultivate algae in lava tubes or harvest ice from shadowed craters, they'll be walking paths first imagined by storytellers who saw the moon not as a rock, but as a living force. The goddesses' greatest lesson wasn't just about the moon's power, it was about our own. They knew that to survive the cosmos, we must learn its rhythms, respect its gifts, and sometimes follow the rabbits into the unknown. The Star of Bethlehem has puzzled scholars for centuries. Was it a divine miracle, or could science explain this celestial beacon that guided the Magi? Ancient astronomers left clues scattered across cultures, each hinting at extraordinary events in the skies around the time of Christ's birth. Chinese court records from 5 BC describe a guest star blazing for over 70 days, visible even in daylight, a telltale sign of a supernova, the explosive death of a distant sun. Halfway across the world, Babylonian clay tablets meticulously tracked planetary movements, noting rare alignments that would have dazzled the naked eye. Even the great Johannes Kepler, centuries later, became obsessed with solving this cosmic riddle. His calculations revealed an astonishing triple conjunction of Jupiter and Saturn in 7 BC, a celestial dance where the two planets appeared to merge into a single radiant point, not once but 3 times over several months. But here's where the mystery deepens. Supernovas leave behind neutron stars or black holes, yet modern radio telescopes find no remnant near the proposed time frame. Planetary conjunctions, while rare, wouldn't have appeared stationary over Bethlehem as the Gospel describes. Some researchers propose another possibility, a comet. Korean annals mention a long-tailed star around 4 BC, and Halley's Comet streaked through the skies in 12 BC, close, but perhaps too early. Others point to Uranus, accidentally observed by ancient astronomers before its official discovery, or even a slow-moving nova flaring in the constellation Capricornus. What makes this detective story so compelling isn't just the astronomical debate, it's how the star's legacy shaped history. The Magi, likely Zoroastrian astrologers from Persia, would have interpreted such an event as a world-altering omen. Jupiter symbolized kingship in Babylonian tradition, while Saturn represented justice. Their union in Pisces, a sign associated with Israel, could have signaled a Messiah's birth. The supernova theory carries equal weight. In Han Dynasty China, such guest stars heralded imperial destiny, while Roman historians like Pliny documented comets as portents of upheaval. Science and myth collide most strikingly in the archaeology of the era. A coin minted in Antioch around that time bears a star and crescent, possibly commemorating the same celestial wonder. The Dead Sea Scrolls speak of a star oracle predicting a coming ruler. Even the timing of Christmas itself may hold clues. December 25th wasn't Christ's likely birth date, but it did coincide with the Roman festival of Sol Invictus, when the sun began its victorious return after the solstice. The star's symbolism, light conquering darkness, transcended cultures, whether as a supernova's blaze or planets aligning like cosmic clockwork. Perhaps the real lesson lies not in proving one theory right, but in recognizing how the heavens have always guided human imagination. The Magi star, whether exploding sun or wandering planets, reminds us that the night sky was once humanity's first storybook, its pages written in fire and motion. Today, as telescopes peer deeper into space, we're still following those same celestial signposts, not to a manger, but to the timeless truth that the cosmos speaks, if we know how to listen. Quetzalcoatl's serpentine form, wreathed in iridescent feathers, slithers through Aztec mythology as both creator and destroyer, a duality that mirrors DNA's own paradox as the architect of life and the blueprint for decay. Modern mythographers point to the striking resemblance between the feathered serpent's twisting body and the double helix, suggesting ancient cultures might have intuited life's molecular architecture long before Watson and Crick unveiled it. While there's no evidence the Aztecs understood genetics, their symbolism pulses with uncanny resonance. Quetzalcoatl didn't just bring knowledge to humanity, he was the wind itself, the breath of life, echoing how DNA's invisible code animates every living thing. This serpentine thread weaves through cultures separated by oceans and epochs. In Norse sagas, Jörmungandr encircles the world with its tail in its mouth, a perfect Ouroboros mirroring the circular nature of chromosomes. Australia's rainbow serpent carves rivers through the land, its undulating form evoking the sinuous path of nucleotides along a strand. Even the caduceus Hermes staff, entwined with twin serpents, has been reinterpreted as a symbolic double helix, its wings hinting at transcendence through biological understanding. What unites these myths isn't just shared imagery, but a profound recognition of patterns, the coiled potential in seeds, the spiral growth of shells, the helical dance of vines reaching for sunlight. Science now reveals why serpents dominate these origin stories. DNA's structure isn't just a biological fact, it's a cosmic motif. Nebulas spin in helical jets, galaxies curl their arms in logarithmic spirals, and even the Earth's magnetic field twists like a serpent in solar winds. The ancients, observing these repetitions from micro to macro, might have sensed a hidden order, one they encoded in myth because they lacked the vocabulary of biochemistry. When the Aztecs depicted Quetzalcoatl shedding his skin, they unknowingly illustrated DNA's replicative process, where strands unwind and rebuild themselves anew. Yet the feathered serpent's true genius lies in its hybrid nature. Quetzalcoatl isn't just a snake, he's part bird, embodying the union of earth and sky, matter and spirit. This duality mirrors how DNA bridges realms, translating inert chemicals into living, breathing complexity. Modern synthetic biologists literally write DNA code as if crafting spells, while CRISPR technology lets us edit genomes like celestial scribes. The feathered serpent's promise to return one day takes on new meaning in labs where scientists resurrect extinct genes, playing creator in ways that would have awed the Aztecs. Perhaps these myths persist because they tap into something primal, the intuition that life's essence isn't straight or simple, but elegantly coiled. From Quetzalcoatl's sacred rattle, said to contain the rhythms of creation, to the sinuous strands glowing in our every cell, the serpent's lesson endures. Knowledge isn't just found, it's unraveled, one graceful twist at a time. Orion's belt hangs in the night sky like a celestial yardstick, its three bright stars perfectly aligned. But look south toward the Giza Plateau, and you'll see those same stars mirrored in stone. The Great Pyramids of Khufu, Khafre, and Menkaure match Orion's belt's configuration with eerie precision almost. The alignment isn't flawless, and that's where the real magic lies. The slight offset between the pyramid's positions and the star's current arrangement isn't a mistake, it's a time capsule. When the pyramids were built around 2600 BCE, Orion's belt sat at a slightly different angle due to a phenomenon called axial precession, Earth's slow, 26,000-year wobble on its axis. The error in the pyramid's alignment perfectly matches how much the stars have drifted over 4.5 millennia. It's as if the builders froze a snapshot of the heavens in limestone, knowing future generations would decode its meaning. The connection runs deeper than geometry. In Egyptian mythology, Osiris, god of resurrection and the afterlife, was eternally linked to Orion. Texts from the Pyramid Age describe the pharaoh's soul ascending to join Osiris in the constellation, becoming an imperishable star. The star Alnitak, Orion's leftmost belt star, was called the string of the apron of Osiris, tying the god directly to celestial coordinates. But here's what's astonishing. The myth hinted at cosmic cycles far beyond human lifespans. The Egyptians spoke of Osiris's periodic return, which scholars now interpret as an allegory for precession, the gradual shift they couldn't have measured in a single lifetime but could track across generations of precise star records. Their myths didn't just describe the sky, they encoded its slowest rhythms. Modern simulations confirm the alignment's brilliance. When astronomers rewind the night sky to 2500 BCE, Orion's belt aligns almost perfectly with the pyramid's layout. The smallest pyramid, Menkora, sits slightly offset from the others, just like the dimmer star Mintoka in Orion's belt. The Nile's course even mirrors the Milky Way's shimmering band in relation to the stars, completing the cosmic map. This wasn't random mimicry. The pyramid's architects intentionally skewed their design to account for precession, creating a monument that would mark both their era's sky and the passage of epochs. The implications are staggering. To recognize precession, Egyptian astronomers would have needed meticulous star charts spanning centuries, records so precise they could detect shifts barely noticeable over multiple generations. The fact that no such written records survive suggests their knowledge was transmitted orally or through architectural codes like the pyramids themselves. The air shafts inside the Great Pyramid add another layer. They align with key stars like Sirius and Orion's belt at specific dates, functioning as a celestial calendar locked in stone. What makes this alignment so profound isn't just its accuracy, it's the worldview behind it. The Egyptians saw time as cyclical, not linear. Their myths of Osiris's death and rebirth mirrored the star's eternal return, and the pyramids were their way of anchoring earthly power to cosmic order. In an age without telescopes or computers, they built a machine to converse with time itself, using myth as their manual and masonry as their medium. The slight mismatch between the pyramids and today's Orion isn't a flaw. It's the signature of a civilization that thought in millennia, reminding us that the stars have stories to tell if we're willing to read them in stone. From the ashes of ancient Egyptian temples to the totem poles of the Pacific Northwest, cosmic birds have soared through humanity's myths as messengers between worlds. The phoenix, consumed by flames only to rise renewed, isn't just a symbol of rebirth. It's a mirror to the Arctic Tern's 11,000-mile migratory loop from pole to pole, a journey that circles the globe like a celestial clock. Hindu scriptures describe Garuda, the golden eagle who carries Vishnu across the heavens, with wings so vast they could block out the sun, an image that takes on new meaning when you consider how flocks of migrating geese can darken the sky for hours. These aren't just poetic exaggerations, they're cultural memories of avian wonders that science is only now beginning to decode. What's astonishing is how these myths anticipated modern discoveries about bird navigation. The thunderbird of indigenous North American traditions didn't just bring storms with its wing beats, it traveled along invisible pathways in the sky, much like real birds tapping into Earth's magnetic field lines. Researchers have found that birds like robins and homing pigeons possess cryptochromes, light-sensitive proteins in their eyes that act as biological compass needles, allowing them to literally perceive magnetic fields as visual patterns. When the Maori of New Zealand spoke of the god Tain separating earth and sky with the help of celestial birds, they might have been describing the same magnetic polarity that guides albatrosses across featureless oceans. The parallels grow even more striking when you examine migration routes. Garuda's legendary flight path between the mortal realm and Svarga aligns almost perfectly with the Central Asian flyway, where bar-headed geese cross the Himalayas at altitudes that would suffocate most animals. The phoenix's cyclical death and rebirth mirrors the annual disappearance and return of swallows, a phenomenon so mysterious that medieval Europeans believed they hibernated underwater. Even the Norse myth of Hugin and Munin, Odin's twin ravens who brought him knowledge from all corners of the world, finds an echo in how crows memorize landscapes across generations, passing migration maps down through social learning. What makes these connections profound isn't just their accuracy, it's the way they reveal humanity's earliest attempts to systematize natural patterns. Before telescopes or tracking devices, cultures worldwide noticed that certain birds arrived with the rains or vanished before winter storms. They wove these observations into myths because stories were their scientific journals, living databases where ecological knowledge could survive centuries. When the Aboriginal peoples of Australia painted the Brolga crane dancing among the stars, they weren't just telling a tale, they were encoding the bird's role as a seasonal marker for monsoon rains. Today, cutting-edge research continues to chase these ancient intuitions. Scientists recently discovered that European robins can see quantum entanglement. Their compass relies on electrons spinning in sync across molecules, a phenomenon Einstein called spooky action at a distance. It's as if the birds navigate by the same cosmic threads that myths described as divine pathways. The thunderbird's lightning now makes sense as a metaphor for electromagnetic forces, while Garuda's golden feathers mirror how some birds use UV light to calibrate their internal compasses. These avian myths remind us that nature's truths often reveal themselves first in poetry, then in data. The next time you see geese tracing a V across the sunset, remember, you're witnessing a living legend, one that our ancestors honored not just with wonder, but with stories that turned observation into enduring wisdom. The birds knew the secrets of the sky long before we did. We just needed their wings to show us the way. Yggdrasil's gnarled roots didn't just anchor the Norse cosmos. They sketched a blueprint the universe uses everywhere. This towering ash tree, with branches scraping the heavens and roots plumbing hidden realms, mirrors the branching patterns found in lightning forks, river deltas, and even the dendritic spread of neurons in your brain. The ancients saw this resemblance intuitively. Hindu texts describe the inverted kalpavriksha tree with roots in the sky and branches descending to earth, while the Mesopotamian tree of life sprouted 7 tiers like a cosmic circuit board. What they couldn't have known is how precisely these myths map onto the mathematics of complexity. Modern science reveals that trees, both real and cosmic, follow fractal geometry, where simple branching rules repeat at every scale. Lightning bolts carve the same jagged paths as capillaries in your retina. Galaxy clusters filament through the void like roots through soil. Even the internet's infrastructure grows in these organic, branching shapes. The Norse weren't just spinning tales when they described Yggdrasil's roots reaching to Jotunheim, Niflheim, and Asgard. They were describing a fundamental truth about how information and energy flow through networks, whether mythological or biological. The eerie accuracy deepens when you examine sacred trees as data processors. The Kabbalistic tree of life isn't just a spiritual symbol, its 10 Sephiroth connected by 22 paths form a near-perfect neural network diagram, with divine energy processing through nodes like neurotransmitters across synapses. The Maya's Ceiba tree, linking underworld, earth, and heavens, mirrors how rainforest fungal networks transmit chemical signals between trees. These myths didn't just imagine cosmic connections, they anticipated modern discoveries about how complex systems self-organize. Perhaps most astonishing is how these tree metaphors align with cutting-edge physics. String theory's landscape of possible universes resembles a fractal forest, each bubble universe budding like a leaf from the multiverse's branches. Dark matter filaments weaving through space, they trace the same arboreal patterns as Yggdrasil's roots. Even quantum foam's ceaseless churn looks uncannily like sunlight dappling through leaves, a reminder that at both cosmic and quantum scales, the universe prefers branching, recursive designs. What the ancients encoded in myth, science now quantifies with algorithms. The Fibonacci sequence governing leaf arrangements also shapes spiral galaxies. The L system rules that generate digital trees could equally model the birth of cosmic webs. These aren't coincidences, they're evidence that sacred trees were humanity's first intuition about the deep architecture of reality. Whether carved on rune stones or glowing in supercomputer simulations, the message remains: the universe grows like a tree, and we're all just leaves whispering on its endless branches. Floods don't just reshape landscapes, they rewrite history. Scattered across every inhabited continent, from the Mesopotamian plains to the highlands of Peru, over 200 cultures share eerily similar stories of catastrophic deluges wiping the slate clean. The Babylonian epic of Gilgamesh describes the god E warning Utnapishtim to build an ark before unleashing waters so violent they shook the world like a raft. Half a world away, the Kayich Maya's Popol Vuh tells of a great flood sent by the heart of sky to punish humanity's arrogance, with survivors clinging to mountaintops as the waters rose. Even indigenous Australian traditions speak of a time when the ancestral rainbow serpent flooded the land, leaving only the highest peaks exposed. For centuries, scholars dismissed these tales as mere allegory until geology revealed they might be some of humanity's oldest surviving disaster reports. The timing is too precise to ignore. Around 12,000 years ago, as the last ice age waned, global sea levels skyrocketed by nearly 400 feet as melting glaciers poured into oceans. Coastal plains that had sustained early human settlements for millennia vanished underwater, including regions like Dogon, a vast fertile expanse now buried beneath the North Sea. But the real smoking gun lies in sediment cores drilled from Greenland's ice sheets. Layers of platinum and nanodiamonds dating to the Younger Dryas period suggest a comet or asteroid may have struck the ice cap around 10,900 BCE, triggering wildfires, sudden cooling, and crucially tsunamis that could have inspired global flood legends. Imagine witnessing walls of water swallowing entire horizons, with no scientific framework to explain them except divine wrath. These myths weren't just stories, they were oral history's version of emergency broadcast. What's haunting is how these accounts converge on chilling specifics. The Sumerian flood myth preserved in the Eridu Genesis describes torrents lasting 7 days, a time frame matching the duration of megatsunamis generated by meteor impact. The Aboriginal story of the Brewarina fish traps tells how ancestral beings built stone weirs to survive rising waters, mirroring real archaeological finds of ancient flood shelters in Turkey's Göbekli Tepe. Even the Genesis accounts detail about the fountains of the great deep bursting forth, aligns with geological evidence of underwater methane eruptions destabilizing coastlines during the meltwater pulses. This isn't about proving mythology true, it's about recognizing how cultures process trauma. When the survivors of these cataclysms told their children about waters swallowing the world, they encoded survival strategies. The Greek myth of Deucalion's Ark carried not just animals but the bones of Mother Earth, seeds, and livestock to restart civilization. The Incan flood legend of Unu Pachacuti specifies that survivors preserved quinoa and potatoes in sealed caves, a real-world parallel to today's Svalbard seed vault. These stories functioned as prehistoric contingency plans, wrapped in divine narrative to ensure they'd be remembered across generations. Modern climate science adds a sobering twist. As rising sea levels threaten coastal cities today, these ancient flood myths feel less like distant warnings and more like grimly practical guidebooks. The same forces that submerged Dogon and glacial melt, shifting ocean currents, are now destabilizing Miami and Mumbai. Perhaps the most valuable lesson hidden in these old tales isn't about the past, but the future. Civilizations that forget their flood stories risk repeating them, this time without the luxury of calling it myth. Ra's golden bark gliding across the sky wasn't just poetic imagery, it was a prescient model of the sun's convective zone, where plasma churns in ceaseless currents. The ancient Egyptians envisioned their sun god battling the serpent Apophis each night, a myth that eerily mirrors modern observations of solar prominences, tangled magnetic loops that writhe like cosmic serpents, occasionally erupting with enough force to vaporize planets. Half a world away, Hindu texts described Sirius' chariot drawn by 7 horses, their manes scattering fiery particles. Today, we recognize these as coronal mass ejections, billion-ton clouds of charged plasma racing outward at millions of miles per hour, a force so potent it could knock out satellites and power grids with a single strike. The parallels aren't coincidental. They're proof that ancient sky watchers noticed patterns we're only now quantifying with satellites like NASA's Parker Solar Probe. Consider Amaterasu, Japan's sun goddess who hid in a cave, plunging the world into darkness until coaxed out by mirrors and dance. This myth encodes a profound solar truth. The sun's activity follows cycles of dormancy and violence. During the Maunder minimum in the 17th century, sunspots vanished for decades, coinciding with the Little Ice Age's frigid winters. Modern heliophysicists track similar fluctuations through the 11-year solar cycle, where the sun's magnetic field flips like some celestial hourglass. Those same mirrors used to lure Amaterasu from her cave, they find their echo in today's solar observatories, where adaptive optics compensate for atmospheric distortion to reveal the sun's seething surface. The real genius of these myths lies in their warnings. Egyptian temple inscriptions described Ra's eye of fire that could scorch the disobedient, a metaphor for X-class flares, eruptions releasing energy equivalent to 1 billion hydrogen bombs. In 2012, a massive CME missed Earth by just 9 days, an event that would have triggered global blackouts lasting years. Ancient cultures prepared for such catastrophes through ritual. The Navajo's Sun Dance, the Inca's Inti Raymi Festival, all designed to maintain cosmic balance. Today, we scramble to harden power grids and shield satellites, finally grasping what these traditions understood instinctively. The sun isn't a passive light bulb, but a capricious deity demanding respect. Perhaps most striking is how these sun gods embodied duality. Surya's Rigvedic hymns praise him as both the destroyer of darkness and the terrible one whose heat parches the earth. Modern climate science confirms this paradox. The same solar radiation that powers photosynthesis also drives desertification. Even Ra's journey through the Juwat, the 12-hour underworld, aligns with the sun's passage through different galactic environments during its orbit around the Milky Way, from molecular clouds to voids. The ancients couldn't measure solar wind or UV spectra, but their myths preserved the sun's essence, a fusion reactor that giveth and taketh away with equal ferocity. Now, as we probe the sun's corona with missions like Solar Orbiter, we're relearning what these deities personified. The Parker probe's discoveries switchback magnetic fields, superheated plasma waves echo descriptions of Rosboat navigating turbulent celestial waters. Our ancestors may not have known about Alfvén waves or heliospheric current sheets, but they captured their effects in stories of gods wrestling chaos above. The lesson endures, whether through myth or mathematics. Humanity's quest to understand the sun remains unchanged, a dance with a fire that could warm us or consume us, depending on how wisely we heed its ancient warnings. Twins have danced across human mythology since the first stories were told celestial siblings locked in eternal embrace. The constellation Gemini isn't just a pair of stars. It's Castor and Pollux from Greek legend, brothers so devoted that Pollux begged Zeus to share his immortality with his mortal twin after death. Half a world away, the Maya revered the hero twins Hunahpu and Xbalanque, who outwitted the lords of the underworld in a cosmic ball game. Even Rome's founding myth hinges on Romulus and Remus, nursed by a she-wolf under the same stars. But here's the breathtaking twist. Modern telescopes reveal that most stars in our galaxy aren't solitary suns like ours, they're binaries, locked in gravitational dances that mirror these ancient tales. It's as if the myths were whispering a truth about the cosmos that science would take millennia to confirm. Look up at Mizar and Alka in the Big Dipper's handle, a double star visible to the naked eye since antiquity. To the Arabs, they were the horse and rider, to the Norse, Thor's lost goats. What ancient stargazers perceived as twin points of light, we now know are often gravitationally bound pairs, sometimes separated by distances greater than Pluto's orbit. The physics of these systems reads like myth, stars pirouetting around a shared center, transferring mass in stellar embraces, even eclipsing each other like quarreling siblings. The Greeks imagined Gemini's twins holding hands across the sky. Today's astrophotography shows binary stars doing just that, their mutual gravity bending space-time into invisible bridges. The parallels run deeper than poetry. Take the Maya's hero twins who journeyed through Xibalba, the dark underworld, before ascending as the sun and moon. Modern astronomy reveals that binary stars often form from the same collapsing gas cloud, literal stellar twins born together, yet their fates diverge spectacularly. One might swell into a red giant while its partner becomes a dense white dwarf, or one could explode as a supernova, leaving behind a neutron star still orbiting its silent companion. These aren't just random cosmic events. They're narratives of kinship and separation playing out on an interstellar scale, just as the Maya envisioned. Even the violent endings in twin myths find eerie counterparts in astrophysics. Romulus slew Remus in a dispute over city walls, a stark metaphor for the gravitational tug of war in close binary systems, where one star can strip material from its partner, sometimes triggering cataclysmic novas. The Aboriginal story of the Watikatjara, two lizard brothers who transformed into the Magellanic Clouds, mirrors how interacting galaxies, like the large and small Magellanic Clouds orbiting our Milky Way, distort each other's shapes over eons. These myths didn't just anthropomorphize the stars, they encoded observable dynamics in the only language they had, stories of love, rivalry, and sacrifice. What's most compelling is how these narratives persist across isolated cultures. The Navajo speak of the warrior twins born of the sun and water, while Chinese astronomy pairs the stars Altair and Vega as star-crossed lovers separated by the Milky Way. Today, we've discovered exoplanets orbiting binary stars, worlds with double sunsets that would have dazzled the mythmakers. Perhaps that's the real magic here, not that ancient people saw human drama in the stars, but that the stars themselves seem to act out these primal stories of connection and duality. The universe, it turns out, has always been a stage for cosmic twins, whether written in starlight or whispered around campfires. Inanna's descent to the underworld begins with a chilling detail. She must pass through 7 gates, surrendering a piece of her divine regalia at each threshold until she stands naked before her sister Ereshkigal, Queen of the Dead. This ritual stripping isn't just symbolic. It's a perfect metaphor for spaghettification, the process where a black hole's tidal forces stretch and compress objects into thin streams of matter. Just as Inanna couldn't turn back once she crossed the final gate, nothing, not even light, can escape a black hole's event horizon after falling in. The parallels don't stop there. Ancient Mesopotamian texts describe the underworld as a place where the dust drinks light, where time flows differently, and where even gods lose their powers, details that could have been lifted from a modern astrophysics paper on singularity physics. Orpheus's doomed quest to retrieve Eurydice adds another layer to this cosmic allegory. His single condition, not to look back until they'd exited the underworld, mirrors the one-way causality inside a black hole's photon sphere, where light orbits endlessly and any glance backward would trap you forever. Greek vase paintings even depict Hades holding a key, symbolizing the irreversible lock of death, or perhaps foreshadowing how black holes lock information within their horizons, a puzzle physicists still grapple with today. The most haunting parallel: Orpheus fails because he's human, because love compels him to look, just as quantum mechanics suggests even the strictest cosmic laws might have loopholes for emotion, in the form of Hawking radiation's slow leakage of information. Japan's Izanagi and Izanami take the metaphor further. When Izanagi lights a torch to see his decayed wife in Yomi, the land of the dead, he triggers her wrath and a chase through the underworld, an eerie echo of how light crossing a black hole's horizon appears frozen to outside observers while accelerating infinitely from the falling perspective. The rotting food Izanami offers him, that could be the quantum foam of virtual particles popping in and out of existence at the event horizon. Even Izanagi's escape by blocking the underworld entrance with a boulder parallels our current understanding of black hole firewalls, theoretical quantum barriers that might prevent anything from truly entering unscathed. What's mesmerizing isn't just that these myths anticipated relativity's time dilation or singularity physics, it's how they encoded these concepts in emotional narratives. Inanna's resurrection after 3 days mirrors the holographic principle's suggestion that information isn't destroyed but smeared across a horizon's surface. The Greek concept of the river Lethe, whose waters bring oblivion, finds a counterpart in the information paradox debate. Does data truly vanish, or is it merely scrambled beyond recognition? These stories weren't primitive guesses. They were thought experiments crafted by minds every bit as sharp as Einstein's, working with the only tools they had: metaphor and observation. The terrifying beauty lies in how these myths grapple with the same questions haunting physicists today. When Ereshkigal sentences Inanna to death by fixing her with the eye of death, is that so different from a singularity's infinite gravitational gaze? When Orpheus's backward glance condemns Eurydice, doesn't it mirror how observation collapses quantum possibilities into fixed outcomes? The ancients may not have known about Schwarzschild radii or Penrose diagrams, but their stories suggest something profound: that human intuition, when honed by generations of sky watching and storytelling, can sometimes brush against truths it doesn't yet have the vocabulary to name. Cosmic eggs crack open across creation myths like a universal shorthand for beginnings. The Hindu Rigveda describes Hiranyagarbha, the golden womb, floating in primordial waters, its shell cracking to release the universe like a yolk spilling into the void. The Orphic tradition in ancient Greece sang of Phanes, the radiant deity hatched from a silver egg woven by time itself. Even the Finnish Kalevala tells of the world egg shattered by a duck's beak, its fragments becoming earth and sky. At first glance, these seem like poetic flourishes until you place them beside modern cosmology's most precise equations. That moment before the Big Bang, when all existence was compressed into a singularity smaller than an atom, behaves mathematically like an egg's perfect symmetry. Infinite density, infinite heat, no space, no time, just potential waiting to unfurl. The parallels run deeper than metaphor. When the Egyptian god Atum emerges from the cosmic egg atop the primordial mound, he's described as the complete one, a being containing all opposites within himself. This mirrors the quantum vacuum fluctuations theorized to have birthed our universe, where particle-antiparticle pairs spontaneously emerge from nothingness, embodying perfect symmetry until the moment of breaking. The Chinese Pangu myth takes this further. The creator deity grows 10 feet daily for 18,000 years, his body stretching to separate yin from yang, an uncanny allegory for cosmic inflation, where the infant universe expanded exponentially in fractions of a second. These myths didn't just guess at origins, they intuited the paradoxical nature of creation, how order springs from chaos, how division begets diversity. Now consider the eternal chicken or egg paradox through a quantum lens. Hindu texts describe Brahman, the ultimate reality, as both the efficient and material cause of creation, simultaneously the chicken and the egg. Modern physics grapples with the same bootstrap problem. Did the laws of physics precede the universe, or did they emerge from it? Quantum gravity theories like loop quantum cosmology suggest time itself may have crystallized from timelessness, rendering the question meaningless, much like the Zen koans that emerged from these same ancient traditions. The Taoist cosmic egg, encircled by the serpent Ouroboros, captures this perfectly, a self-contained system where beginnings and endings are illusions. What's revelatory isn't just the accuracy of these myths, it's their methodology. Without telescopes or particle accelerators, ancient cultures conducted thought experiments using narrative. The Dogon people of Mali described the egg of the world vibrating before creation, resonating with string theory's notion of vibrational dimensions. The Norse Yggdrasil, the yawning void where fire and ice collided to birth the cosmos, reads like a prescient description of vacuum decay, where opposing energy states catalyze new universes. These stories weren't primitive science, they were proto-science, using symbolic language to explore questions we're still answering with equations. Perhaps the most profound insight lies in the egg structure itself. A fragile shell protecting infinite potential, requiring precise conditions to hatch. This mirrors the fine-tuning problem that stumps modern physicists. Why do fundamental constants like gravity or the speed of light have values that allow for stars, planets, and life? The Zoroastrian Tishtria myth offers a poetic answer. The world egg was fertilized by a divine spark striking at just the right angle. Today, we frame it as the anthropic principle, but the essence remains. Creation isn't random, it's a story of perfect conditions meeting infinite possibility. When we crack open these ancient eggs, we don't find outdated beliefs. We find the first whispers of cosmology, waiting patiently for science to catch up. Star-crossed lovers have wept in every culture's myths, their tragedies written in the language of celestial forces. The Chinese legend of Xinu and Niulang tells of a weaver girl and cowherd banished to opposite sides of the Milky Way, permitted to meet just once a year when magpies form a bridge across the starry river. What's astonishing isn't just the poetry, it's how closely their story mirrors the brutal mechanics of real cosmic separations. When two stars orbit too closely in a binary system, their gravitational dance can end in catastrophe. One might siphon material from its partner until it explodes as a supernova, flinging the survivor across the galaxy like a heartbroken wanderer. The myth's Magpie Bridge finds its counterpart in the delicate filament of gravitational attraction that persists even after stellar divorce. Romeo and Juliet's fateful orbits drawn together only to collide echo the dynamics of rogue planets torn from their home systems. These interstellar orphans drift through the void, their trajectories altered by passing stars like cosmic feuds pulling lovers apart. Even the rare ones that find new homes often end up tidally locked, one face forever turned toward their adopted son in an eternal, frozen embrace. The same forces that sculpt galaxies also shape the oldest love stories, attraction strong enough to bend spacetime, separation enforced by inexorable physics. Yet some myths hint at reconciliation. The Navajo story of the hero twins, born of the sun and water, describes their transformation into the morning and evening stars, a celestial balance where one rises as the other sets. Modern astronomy reveals this isn't just symbolism. Venus's dual appearance as both morning and evening star occurs because its orbit lies inside Earth's, its position forever alternating like lovers taking turns keeping watch. The gravitational resonance between these worlds is so precise that for every 8 Earth years, Venus completes almost exactly 13 orbits, a numerical harmony the ancients encoded in their sacred calendars. The most poignant parallel lies in orbital decay. Just as Shakespeare's star-crossed lovers spiral toward their tragic end, binary black holes inevitably merge after eons of circling. Their final moments radiate gravitational waves, ripples in spacetime that sing across the universe at light speed. When LIGO detected these waves in 2015, scientists translated them into sound, a cosmic chirp rising in pitch before abruptly cutting off. It's the same cadence as Xenu and Niulang's fleeting reunion, the same crescendo as Romeo's last breath, a proof that the universe has always understood the grammar of love and loss. Whether written in starlight or sonnets, the story remains unchanged. Gravity binds, time divides, and only the echoes endure. Giants loom in the shadows of nearly every ancient culture, not just as stories, but as living, breathing threats that once walked the earth. The Bible's Nephilim, mighty men of renown, tower over early Genesis like relics of a forgotten age. Greek titans strain against their chains beneath volcanoes, while Norse Jotun breathe frost across creation myths. These aren't just metaphors, they might be ancestral memories fossilized in folklore. When paleontologists unearthed woolly mammoth bones alongside Stone Age tools, they proved humans once shared the landscape with creatures that defied modern scale. A standing mammoth could reach 13 feet at the shoulder, its tusks curving like the weapons of a storybook giant. To a hunter-gatherer staring up at that silhouette at dusk, the line between animal and myth would have blurred instantly. But the connection runs deeper than size. Consider the Cyclops legend originally sparked by Greek farmers stumbling upon Danatherium skulls, their nasal cavities mistaken for single eye sockets. Or the Sioux tales of Untehai, colossal water monsters that match the fossil records of prehistoric rhinoceros-like beasts that wallowed in ancient rivers. Even the biblical behemoth, described as a creature that eats grass like an ox with bones like tubes of bronze, reads like a folk memory of encountering a Paraceratherium, the largest land mammal ever, a hornless rhino that stood 18 feet tall. These myths didn't emerge in a vacuum, they're cultural scars left by encounters with a world far stranger than our textbooks suggest. The most haunting evidence lies in extinction timelines. When humans crossed the Bering Land Bridge into North America around 13,000 years ago, they entered a continent teeming with megafauna. dire wolves with bone-crushing jaws, saber-toothed cats with 12-inch fangs, ground sloths the size of elephants. Within centuries, most vanished hunted to extinction or outcompeted. Indigenous oral traditions preserve the shock of this loss. The Cherokee legend of the Octina, a giant horned serpent, may encode encounters with the extinct Titanoboa, a 50-foot snake whose vertebrae still surface in South American mines. The Algonquin stories of the underwater panther match the behavior of the short-faced bear, an apex predator that could run down horses at 40 miles per hour. What's revelatory isn't just the overlap, it's how these myths process ecological trauma. The Norse described Jotun as forces of chaos battling the gods for control of the world. Modern ecology confirms this narrative. Human arrival often triggered trophic cascades, where killing megafauna destabilized entire ecosystems. The giant's downfall reshaped forests, rivers, even the climate itself. Changes later generations would mythologize as battles between order and chaos. When the Maori recount how their ancestors hunted the moa to extinction, their stories speak of the giant bird spirits still haunting the mountains, a poetic reckoning with humanity's role as both predator and mourner. Yet some myths hint at coexistence. The Siberian Yukagir people tell of Kodioda, a mammoth-like spirit that survives underground, its occasional surfacing causing earthquakes. In 2018, scientists discovered liquid blood and muscle tissue in a 28,000-year-old mammoth carcass from the region, proof that some specimens are preserved so perfectly they seem to sleep just beneath the permafrost. The line between legend and paleontology blurs entirely when you consider that the last woolly mammoths on Wrangel Island died out as recently as 1600 BC, contemporary with Egypt's Middle Kingdom. For Bronze Age civilizations trading tales across the Mediterranean, mammoths weren't prehistoric relics, they were recent memories fading into myth. This collision of bone and folklore forces a radical question. Could humans have an instinctive understanding of Earth's deeper past? The Aboriginal Dreamtime stories describe landscapes shaped by giant ancestors, precisely the terrain megafauna sculpted through grazing and migration. The Amazon's terra preta soils, enriched by centuries of giant sloth dung, are still sought by farmers who call them the earth of the ancients. Our myths might be more than stories. They could be inherited maps coded with survival knowledge from epochs when giants really did walk the earth. Every time a child shivers at a giant's tale, they're not just imagining, they're remembering.